start with radial distributed system, and today we will discuss the basic techniques. Basic techniques. Reliability evaluation of distributed system is different from reliability evaluation of other generation and transmission systems. It's completely different, totally different. Okay, we'll see how it is done. Why it is different? The distribution system is relatively cheap and outages are local. The generation system goes out, you never know where the impact is hit. But distribution system outage is only applicable for the area it is connected to. The analysis of customer value statistics of most utilities show that distribution systems make greatest individual contribution to on average. Right? It is only the distribution systems. If they fail, customers do not get power even if the generator systems are operating. Isn't it? Right? Statistics of unavailability reinforce the need to be concerned about reliability of the quantity availability. Which is, if you find out the choke points or where the diffusion system fails, generally you are going to provide reinforcement. Some more, maybe more lines, okay, more transformers. There are aspects of the concept. Large sums of money are invested collectively because of the transformers. The ensure balance and reliability of various components of the power system. Evaluation of alternatives and the allocation of spares. This part we will discuss later in the last module. Maintenance policies. Now the question is what techniques we are going to use. In during generation we use LOE concept. LOE, all these concepts we are using. Probabilistic approach. The other one was frequency duration approach. The same thing we apply for transmission systems also, right? But for distribution systems, these are different, and these are also different from for systems, whether the system is radial or mesh. You need to write down these three equations. You will be asked us 2-mark question, or these are the building blocks for evaluating distribution system reliability. Write up the equations as I tell you. So these three are the most important equations for basic right up. A radial distribution system consists of a set of series components including lines, disconnects, isolator and bus bars. Series components. A system for which we find reliability is generally considered to be either a parallel component or series component. In distribution system case, series components. Series components are a very difficult situation with radial systems. If one component fails, everything in that line, in that series fails. That's right. Customer connected to any load point of such a system requires all components to be operated. So in a series system, all components must be operated. If any one fails, bus bar fails or disconnect fails, anything fails, no system. The principle of series system can be applied, which is part of reliability engineering. And we are going to find out this. So what is the average failure rate? It is the summation of the failure rate of individual components, lines, bus bars, whatever. Average annual outage rate is simply equal to summation of lambda Ri, where Ri is the Ri is dependent. It's not exactly repair rate, we will see in detail. Next slide. Average outage time. Average outage time is equal to annual outage time divided by this one. You see exactly what Ri means in the next slide. Can you write down this? Interruption indices can be divided into two types. It's very important. You might be asked a question, 2-mark question in the exam. What is the difference between customer-oriented indices and load-oriented indices for a distributed system? Okay. So we have got two types of indices: customer-oriented indices, load and energy-oriented. And what is the distinction? By the end of the slide, we will be clear about what is the distinction between customer-oriented and the energy-oriented indices. Where do we discuss? It's not exactly repair. Okay. Now, these are some of the terms that we are going to evaluate. And suppose you are going through a research paper, latest research paper, say it's 2026, and you have the paper is on reliability, on microgrid reliability. Okay. And you are going to see all these terms. So you need the basic knowledge of what are these terms. Okay. Every presentation, suppose you are attending on power systems, they will be referring to these terms. So you need not write down everything now, but just mention the terms. Okay. So what is the first term? First is system average interruption frequency index. Just write down this abbreviation side B. System average interruption frequency index is equal to lambda I Ni divided by Ni. Where lambda is the failure rate, Ni is the number of customers at the low point time. Just write down the abbreviation and the formula. This is basically total number of customers divided by total number of customers served. No need to write down the details, that you can read it. The next one is customer average interruption frequency index. Customer average interruption frequency index. Total number of customer interruptions divided by number of customers affected. Okay, just write down interruptions divided by affected. Just write down that in short. System average interruption division side. So what is that? That is equal to summation Ui Ni divided by summation Ni, where Ui is the outage time. Write down the abbreviation and the corresponding formula. Okay. Next, the other two are customer average interruption division index CAI that is equal to summation Ui Ni divided by summation lambda Ni. Ni is always the number of customers. Then average service availability index ASAI that is equal to Ni difference Ui Ni. Just write down this. That is customer hours of available service divided by customer hours demanded. And then this is average service availability index. The other one is average service unavailability index, which is simply equal to 1 minus ASA. So write down. Okay. Next. That is all about customer related cases. Then we come to load or energy related cases. So you need to write down this. So average load LA given by equal to average load by Q2. Okay. Average load by so here L is taken as the load factor. And what is average load? Average load is total energy consumed divided by the duration. Total energy demanded in the period of interest divided by period of interest. 1 year. What is total energy in 1 year divided by number of hours? So that is the average load per hour. Energy not supplied index. What is that? Total energy not supplied by the system. Average into unavailability. UI we have already defined in the first slide. That is basically you can write annual outage time. EY is equal to annual outage time. Okay. So one more indices is energy not supplied. Next. The other one is average energy not supplied or average system curtailment index. So what are these two? Average energy not supplied equal to total energy not supplied divided by total number of customers. From previous slide. Average customer curtailment index, total energy not supplied divided by total number of customers. Write down in detail. Okay. Next is based on this indices, customer load related indices, we are going to estimate system performance. So customer and load point indices are very useful for assessing the severity of the system failures. And for future gravity prediction analysis, this can also be used to assess the past process. So how to assess the system performance? So these are actually chronological change in the system performance, and therefore we have to identify which area to improve. We will compute all these indices over various years and see whether the system is actually improving or, for example, for previous past 1 year we are seeing lesser power interruptions. Here we should. Okay. Remember previous predictions we compared with actual operating. So these are the muted. So this is the example that we are going to solve. Write down this data. Write down this data. So we are considering a radial distribution. It's a radial system having 6 load points. There are 6 load points each. The customers are connected. In a radial system, you know what it is. There are 6 load points. 6 load points. The number of customers and average loads connected is given. As in that 4 system failures occur in one given calendar year of interest. So 4 failures per year. From here you can get the failure rate. Compute the various load point and customer rate. Suppose this example comes in the exam. So all the indices it will be 8 marks. So if you compute suppose 8 indices, so it will be 8 marks. Okay. So there are 6 customer points. To each 1 point, 1000 customers. Average load is 5,000. 800 customers, this is 0 kilowatt. 600 customers, 0 kilowatt. 800 customers, 3.0 kilowatt. 500 customers, 2.0 kilowatt. 300 customers, 300 kilowatt. Maybe a village or a locality for a transformer. Okay. 1000 customers is suppose 1 hostel, 2 hostels, 1 transformer. It will be 1000 kilowatt. how many interruption cases are there? 4 interruption cases. You told, right? 4 interruption cases per year. You have written in the question. 4 interruption cases per year. So these are those 4 cases. In this case, in the first interruption case, only point 2 and 3 are affected. You can draw that radial line. Radial line connect loads, 6 loads. Draw a line. Radial, you can draw vertical, horizontal, in your choice. Okay. Draw a line and connect 6 load points. Now you see, and just write down the number of customers in bracket. How many customers? Just write down there. 1,000, 800, 600, 800, 500, 300. You mention there. And those load points. Just mention the number of customers. Now, for the first interruption case, there are 4 such cases in here. So, first case, load point affected is 2 and 3. So, what is the total number of consumer connected to 2? How many? 800. Number of customers disconnected 8. Because that load point what is? 0.367. Number of customers disconnected is 6. Interruption to only load point affected is 6. So 300. Interruption third, load point affected is 3. That is 600. Interruption 4, load point affected is 5. 500, also 6. 2 points are affected. That means in this interruption, 2 points are disconnected. All those customers were disconnected. Total number of customers disconnected because of all these events during the whole year. Yes. So these many consumers were affected. So this is NI, right? Right? Number of customers affected N. You can mention that. Total number of customers is right. Total number of customers N is equal to 4,000. Number of customers affected by interruption is equal to 310. Number of customers affected by interruptions equal to 310. Got it? Now this information is the average load, okay? Not individual load, the average load. Now this information is also given, that is at 4.2 number of customers affected is 800, whereas the load curtailed is equal to 3600 kilowatt is given. Right off. See that the load curtailed because of this outages or events. Total load curtailed will be 50,200 kilowatt. Load curtailed daily. Load curtailed. Now, in the question it was written there are 4 interruptions in the year, complete year. So, out of the 4 interruptions, the first interruption is a 3-hour duration. The second interruption is a 2-hour duration. The third interruption is a 1-hour duration. Whereas the fourth interruption is a 1.5-hour duration. That will also be given. This data needs to be given, provided you duration of the interruption. Now what is the use of this duration of the interruption? Now the load curtailed is 3600 kilowatt. What is the energy curtailed? Energy curtailed is equal to load curtailed into the duration. 3600 into 3, how much? 108. 10800 kilowatt hour. This is required for calculating one index. So it is computed here. But we have calculated this now. Total energy loss applied is 108 double. Similarly, we can compute for others. 0.003, 1 This is the total energy that this two will not be provided. This last two columns you have to calculate. Okay, this two will not be provided. But after this information, all the information will be provided. Okay. Why it is required? We see by computing some. Okay. So our objective is to compute how many? 1, 2, 3, 4, 5, 6, 7, 8. This is simply 1 minus this. So you need to compute all these 8 to get 8 marks. Your exam. So that I will provide. So what is cycle? Tell me the formula. Say fine. What is the formula? Read out.
So this is lambda by Ni divided by Ni.
Lambda
Ni divided by Ni.
Lambda is failure. What is the failure rate here? K12, right? K12. It is here. What is the numerator? From the presentation you read out numerator. Total number of customers. Numerator. Numerator is total number of customers. Interruptions. Divided by total number of customers served. That means that denominator should be 4000. That is 4000, right? Denominator is 4000. So write down 4000. Cycle is equal to the denominator you write 4000. Okay. Which is equal. My formula is equal. Equal. Okay. That is 4000. Denominator is 4000. Now what's the numerator? Numerator is equal to number of customer interruptions. What is the number of customer interruptions?
3100.
3100. What is it again? Let's see.
Given sales and pay.
Total number of customer interruptions. Okay. Failure into number of customers affected. Okay. That is equal to K12. K12. That is how many customers are disconnected. So 3100 divided by 4000. Okay. That is equal to 0.775. Right? Hello. Okay. Next one. Next one is CAIFI. That is equal to second one is total number of customer interactions divided by total number of customers affected. How to find out total number of customers affected? At a particular disconnection, which load points are affected and how many customers are connected to that load points. That is equal to total number of customers affected. Whereas here it is total number of customers connected, total, right, total. Here the number of customers which are affected by that interruption. Okay, it is now is equals is actually 3100 in our case. See, this is E7, E8, E10, E11.
So 2, 3, 6.
E7.
So there are some repetition in the load point affected. So there are four interruption cases. So we have taken
Number of customers interrupted divided by 7, 8, 10, 11. 4.2, 3, 5 and 6. Is it so? Yes. Only 2, 3, 5 and 6 are affected, right? Number of customers connected to those load points. Right, our headphones will be next. SID. Sum of customer interaction durations divided by total number of customers. That means this is 4,000, right?
Yes, sir. Operators are 6600. 6600.
Yes. Okay. Divide.
1.65.
Why is 600?
So because total number of hours customer content.
Into customers content. So see in the this is this one. Okay, that's why you are calculating this. This is the number of customers is connected into the customer duration. Okay. And you sum it up. So this becomes 600 divided by n 12. So this is 6 n 12 divided by e12. E12 is total number of customers. Next, CAI duration index. So CAI is what is the formula? Sum of customers interaction duration divided by total number of customers. Is that equal? Same. What is this? What is this? It's like a 660. 660. What are it? Summation lambda n total number of customer interaction. 3122. Is it? 3.12. We will check. Yes. 3.12. Next. ASAI. What is ASAI?
So total number of customer into 860 minus
Customer hours of available service divided by customer hours demanded. Right? Did you write this formula? We did about 4,000, huh?
Yes, sir.
Yes, sir. It had been 4,000. 4,000
4860 minus 660. Sir, minus 660.
Minus
660.
is it? Okay, get it out.
0.999812.
Wow.
812. Okay, 811
Yes. So as you see there, equivalent to x160 minus n12. N12 is this one. N12. Now this is availability, this is unavailability. So this is simply 1 minus this. Yes, this is more important. That is energy not supplied. But if the total energy not supplied, then directly calculate from here. So already calculated. The total energy not supplied. KNS. 1 minus KNS. What is the total?
divided by divided by 400.
This
It
is
is 31,900 divided by
4,000. Okay, average energy not supplied. Divided by 4,000.